Hi guys, today I'll be teaching you about logarithms. Now, as you know about exponents. So 2 to the power 2 is 4 and you know about exponents. Anything to the raised to the power anything is known as an exponent. A logarithm is an inverse of an exponent. So, for example, if I draw a graph, so I'm expecting that you know about exponents and logarithms, and of course about functions, because because exponents basically y is equal to 2 to the power x. Basically, they are functions of x is equal. So I'm expecting you know about functions. So let's draw a graph of an exponent. For example, here's a graph of an exponent, and I want to draw. So an inverse of a function, as you know, is its reflection about x is equal to y line. So this is x is equal to y line. I'm drawing the x is equal to y line, and its reflection would be like this. So to find an inverse of a function, we just have to draw the reflection of that function, which will be its inverse. So you might have heard about sine inverse and stuff like that. Those are just reflections, and other functions are just reflection of that function about x is equal to y line. So basically, this line can act as like a mirror, and the mirror image is this. So this is my logarithm line, this is my log line, this is my log line, and this is my exponent line. So these are inverse. So logarithms are basically the inverse function of exponents. So now let's get into how we work with logarithms. Let's start. I'm gonna erase this stuff, and um, I'm going to start. So a logarithm, we can denote something. For example, you might want to solve the problem. For example, 2 to the power x is equal to for example 6. You want to solve for x. So what do you do is you check in the calculator. 2 to the power 2 is 4, 2 to the power 3 is 8, 6 is nowhere between. So you basically round off some value of x and put it there, and in compound interest questions and like that. So an easier way to denote this is logarithms. To find the exact value of x, we use logarithms. So it is denoted by a log symbol. It has a base, just like an exponent has a base. Its base would be 2. Here we will write the answer 6 is equal to the value of the exponent. So this is a representation of this formula right here. How? Log, we say this expression as log 6 base 2 is equal to x, which means 2 is the base, 6 is the answer, and x is the power. So we have to find what power 2 to the power what power gives us 6, and that is x. So 2 to the power x is equal to 6, which is just this expression. So in order to calculate, we have a rule here. I'm just gonna erase it so that I have more space. I'm gonna rewrite it, don't worry. So I'm gonna write it in, so log 2 6 is equal to x. Now we know that so this is the rule. Okay, we don't know it. So log base, so I'm writing an expression, log base a b can be denoted by log b over log a. So anything with log, so a log which has a base and has a answer in front of it, we can write it as this expression right here. So log, so this can be written as log 6 over log 2 is equal to x. Now there's a function in your calculator which is known as log, and just type log 6 divide by log 2 and you'll get the value of x, the exact value of x. So now we're going to solve problem about logs. Now I've explained it. So what are logarithms and how it works. I hope you've understood this. Now we're gonna go at problem solving of logarithms. So here is a simple question for you. Log 416 is equal to what? Find the value of log 416. Give it a try, pause the video and see how will you do it. I hope you've done it now and I'm going to show how I did it, how we'll do it basically. So log, the base is 4. You can write the base as 4. The answer is 16. The answer is 16. And the exponent is this value right here. 4 to the power, let's take it as x. 4 to the power x is equal to 16. Now we know that 4 to the power 2 is 16. So x will be equal to 2. Sorry for that. So x will be equal to 2. And if you had done log 16 over log 4, you would have gotten the same answer. So this is like the basic question. This is the easiest question of logarithms you can get. It it gets tough when you go into this detail and differentiation of logarithms and higher problem solving. So the tough problems I do them in this video itself. If you can, very good. It's very good. Logarithms are not that tough. The logarithms are easy, but you need to apply your brain when you are doing tough questions. So I am writing a rule here, right here. Base a, log a base a is equal to 1. So anything when the base and the answer is same, the power will be 1. That is like common sense. So a to the power what value should be equal to a? Well, a to the power 1 is a, so that's why so for example, if I write log 24 something like that and 246, so 246 sorry, so base is 246 and I write 246 here, so the answer will always come out to be 1 no matter what the value of a is. So let's move on to problem solving. When you there are many more rules of logarithms. When we'll do those problems, I'll automatically introduce you to them, so don't worry. So I'm gonna give you a slightly tougher problem here. Log base m square root of m to the power 5. You have to simplify this expression. You can take out the answer as well, but I'm asking you to simplify. So pause the video and give it a try. So the way we do this is log m and m to the sorry m to m. So we know that square root is a power half. Okay, so m to the power 5 to the power half. M to the power 5 to the power half, and this will become log base m to the power 5 by 2. So in this expression, it's not completely simplified. There is another rule which comes into play. That is log. You can copy these down in your notebook or somehow, so you are familiar with these rules. And this rule is quite good. It comes into use in a lot of problems. We'll do this in this video too. So for example, log a base b to the power x, you have to simplify this. This can be written as, so the answer is b to the power x. Okay, the answer is b to the power x. A is the base and here is the exponent. So if you want to simplify this expression, simplifying this expression would simply mean, so if you want to simplify this expression, it will be x into log ab. So for example, I like I write log 10 5 square. Now we know that 5 square is 25. You can write it as log base 10 25, or you can write it as 2 into log 10 5. So this power right here, basically it goes here and it multiplies itself with this value. Okay, this is an easy rule. So let's go back to that question. I'll erase this real quick and let's go back to that question. Oh, this eraser, the brush size is full, I can't do it. So log base m to the power 5 by 2. So we know that in the rule before, 5 by 2 is the power. It will go here and it will multiply itself. So it will be 5 by 2 into log base m, and this is the simplified expression. But what if you want to find the value of this expression? Log m or log m to the power 5 by 2 base m. You want to find this value here. So this is the simplified version, correct? This is correct. But we notice one thing here. In the previous rule discussed before, log base m log m base m. So anything with a similar answer and a similar base. So m to the power what should give you 1. So we discussed that log base a is equal to 1. So log base m should also be equal to 1, which will give us 5 by 2. This is our answer. 5 by 2 is our answer. So the answer of this question is 5 by 2. So I hope you've understood logarithms and what they are, the basics of logarithms, and go, and if you haven't studied about functions, doesn't matter, you do these problems first and then you'll grab those and you'll find that logarithms are always the inverse of the exponent function. Now we are going to do another problem which is slightly tougher. Here is one problem for you. Before that problem, I want to introduce another rule to you. So for example, we have log any base. So let me tell you one thing. So for example, if something is written log 5 here, log 5, and you're wondering the answer. So you're like, what? We have no base. How can we give an answer without a base? So, well, the default base is 10 always. So whenever you see an expression, for example, log x written here, so it is equivalent to log x base 10. 10 is always the base in this case. There is another base which is ln, and you will find it in your calculator. Ln, it stands for natural log. That will be in another video. So now if I'm going to give you questions which doesn't have a base which is written, just assume it to be a base of 10. Okay, so I'm going to give you a question now and another rule. So I'm going to give you the question and the rule will be included here only. Log 3 minus log 3 3. Now in this question there is a rule applied. That rule is log with a base. For example, base is a, and for example, and the answer is 10 divided, excuse me, sorry. So for example, the log is base 10. You can take any base. You can take it as a, any variable. So for example, it's written like that, log 5 and log 10. The base 6. So this expression can be written as, so it is log 5 base 10 minus log 6 base 10. So this can be written as log base 10 and 5 divided by 6. 5 divided by 6. Okay. So for example, log a base b minus log a base, for example, y. Okay. So it can be written as simply log b over y. Okay. This is one rule. And similarly, if there would have been a plus sign in between, it would be log 10 5 into 6. Okay. So what if whenever there's a plus sign between and there are two logarithms on each side, the the answers the answer which comes here will be just the multiplication of both the answers. So for example, it's log base 10 5 plus log base 10 6. It would be log base 10 5 into 6. Now what if I changed the base here? What if I made it 4, for example? Now in this case, the base isn't same, which means you can't just write the same expression here. The base, if the base is same, that rule is only applied when the bases are same. The base is not same here, so you can't do anything about it. Shoot. So in the above question, you've been given a logarithm, three logarithms with the same base. Let's solve this question. So first we'll perform this operation right here. If there are three logarithms, you can't do 6 divided by 2 divided by 3. Okay, so you do log 3, 6 divided by 2. 6 divided by 2 is 3 minus log 3, 3. Okay, and we know that wait, am I correct? 6 divided by 2 is 3. Yeah, I am correct. So we know that log 3, so this is 1, this is 1, which will give us the value as 0. Or if you want to do the division rule, you just do log 3, 3 divided by 3, which is 1, and anything raised to the power 0 will give you 1. This is my answer. Now there will be more questions. I'm going to give you one more question, no, actually 3 or 4 more questions, so that uh, you'll become an expert in logarithm. Basically, I'm not boasting, but yeah, because these questions are intermediate. At the end of this class, I'm going to give you a tough question, slightly tough question. So yeah, and in the next class of logarithms, there will be an extremely tough question which you have to solve. And if your basics are clear in any type, in this topic, so you will be able to do any problem. The basics of logarithms have to be clear. So if you do any problem and your basics are clear, even if it is a CAT question or any tough question, you can easily do it. So the second question I will give you is 2 minus half log n 4 minus log base n 5. We know the division rule, that rule, when the base is same, you can do that stuff. So let's apply that rule here. So first we're gonna simplify this expression. Can you notice something here? There's a half into log n4, and we learned that x log a b is equal to log a b to the power x. We learned that, right? So this would simply become half log base n4 would simply become log base n4 to the power half. I'll write that down. 2 minus log n4 to the power half, and this would become this would become 4 to the power half will become 2, right? So and minus log n5. Let's solve this question. So 2 doesn't have like a base n or something. Can we, so in order to apply the division rule, we have to convert this into an expression which involves log base n. How can we do that? Well, if you're intelligent enough, 2, we'll put 2 outside and put log n, right? So is this expression equivalent to this expression? Yes, it is, because it is 2 into 1. Log base n is equal to 1, which will give us 2 eventually. So it is base log n base n, which is 1 into 2, which gives us the value of 2 itself. And one more thing, the same rule again. So log base n and 2 is here in front of this. So this will go here and become a power. So it will become log base n square minus log n 2 minus this expression. So first we're gonna do log n n square by 2, right, minus log n5 log n5, right? So this would become log n square divided by 2 divided by 5 will be n square divided by 10. So this is our simplified answer. I hope you understood this question. I know my workings aren't tidy because um, I don't know how to like write fluently in Smooth Draw or software. If anybody has some ideas, please suggest me. I'm tired of um, being so fiddly with these tools. Um, Now I'm gonna give you one last question. I'm gonna give you one last question. Just one last question. Okay. Log base 2 p is equal to x, comma, log b3 is equal to q, and log b5 is equal to r. These are our expressions. Now the question is, wait, sorry. Question is log, write it a little, log base 2 r square root q over p cube. I have to simplify this value in terms, and I have to write this expression in terms of, q, x and r. Okay, so can you notice one thing here? Sorry, I'm just gonna erase this real quick. Can you see one thing here, that can we develop a relationship? Can we develop a relationship with R and these logarithms? Yes, we can. So if log 2 base 2p is equal to x, then can we write it as 2 to the power x is p? We can write it as this, right? And for this too, we can write it as b to the power q is equal to um, oh wait, I copied my question wrong. Sorry. So 2 to the power x is equal to p, and then log base 2q will be equal to y, and log base 2r log base 2r will be equal to z, right? So we have to write this in terms of r, z and y, x, z, and y. So 2 to the power x is equal to p, that is established. Then 2 to the power y is equal to q, agreed. And you can see, so 2 to the power, 2 to the power x will be equal to p. That was the first part of the video. I hope you remember it. If you don't, go back and watch it, please. And b and log 2 to the power z will be equal to r. 2 to the power z will be equal to r, right? So we can write, so first we're going to simplify this expression. Now r is what? R is 2 to the power z, so r square will be written as 2 to the power 2z into root q is 2 to the power y into root 2 to the power y upon this is p cube, right? My handwriting is so bad. Upon p is 2 to the power x, so it will be 2 to the power 3x, which will give us 2 to the power 2z plus y upon 2 upon 2 to the power 3x. So I'm out of space. I'll erase this part. So this can be written as 2 to the power um is this 2z? Yeah, this is 2z. So 2 to the power 2z plus y upon 2 minus 3x is equal to this value right here, this expression. So we have simplified our value right here. So this is gonna be awesome. Wait, it's gonna be awesome. Yeah, so we know that now log base 2, this log base 2 right here, and this value. Basically, what I had done is simplified this in terms of z, y, and x. So this would be log base 2 to the power 2z plus y upon 2 minus 3x. Right? Now, see that rule before, that log base 2 is here and 2 has some power. This will go back here again and it will multiply itself. So 2z plus y by plus y by 2 minus 3x into log 2 base 2 2. Okay, now we know that log anything, so we knew that log a is equal to 0, a to the power is equal to 1, a to the power 1 is equal to a. So when the answer and the base is same, when the answer and the base is same, we get 1, we get 1. So the answer of this expression right here in terms of z, y and x will be this, and you can take the denominator same. So I hope my handwriting and my erasing didn't cause you much confusion. If it did, you'll you can tell me to make another video and I'll be like more clear and come up with a better software. Any suggestions, please put in the comments below. And thanks for watching. Don't forget to subscribe. And in the next class, I'll be teaching you more about logarithms, more difficult questions about logarithms. These are so in this class I basically cleared your concepts about logarithms. Okay, logarithms are just this part. Okay, it's not that tough. The name is quite fancy. Mathematicians want to show off, but doesn't matter. Logarithms are just so easy. Don't forget to subscribe.